This is the first video on chapter 45, the area between curves. So what we're going to look at here is we have these two functions that are continuous, and we want to look at a region bounded by these two functions. And I'm going to explain Theorem 346 a little bit. I'm going to do one example in this video, and I'll do two examples in the next video. So here, our functions are not necessarily above the x-axis. So we have y is equal to f of x, y is equal to g of x, and we're going to set, we know that a continuous function on a closed interval has a maximum and a minimum. That means f has a minimum. We're going to call f's minimum c. And then what we're going to do is we're going to do a vertical shift of these two functions up by the absolute value of c. So here c is a negative number, so we take the absolute value, make it positive, and we shift these two functions up that positive amount. And I mean for this curve to be the same as this one, and the top one here to be the same as the top one here. So this curve is just y equals g of x plus absolute value of c. This one is f of x plus absolute value of c. So we have just shifted both functions up by the amount of absolute value of c. Now here, to find the area between the curves, we simply find the area from a to b under the curve y equals g of x plus absolute value of c. Then we find the area under the curve y equals f of x plus absolute value of c, and we subtract. So we take our larger area minus our smaller area, and that's the area between these two curves. But by our properties of integrals, we know the integral of the sum is a sum of the integrals. The integral of the difference is a difference of the integrals. And so we can just integrate g of x plus absolute value of c minus the quantity f of x plus absolute value of c. The absolute value of c's cancel, and we just end up with the integral of g of x minus f of x. And so it doesn't matter that our two curves aren't above the x-axis. The area between them is still just the integral of the difference, or the difference of the integrals. So our first example, example 347, part A, we're going to use Theorem 346. Now the thing about Theorem 346 is we have to know which function is the larger function and which one's the smaller function. So we want to find the area of the region bounded by the parabola y equals x squared plus x minus 9 and the line 2x plus 3. This parabola opens upward, and this line has positive slope. So this is the only way that this region, that we can have a region bounded by these two curves. If the line came down here and missed the parabola, then we would not have a region bounded by these two curves. So we have a parabola that opens upward and a line with positive slope. We want to find the points of intersection, so we solve the quadratic equation. X squared plus x minus 9 is equal to 2x plus 3. And so I've written the details in the notes, but we're just solving a quadratic equation. And so x is equal to negative 3 and 4. These are our two solutions to the quadratic equation. So we integrate negative 3 to 4 of the larger function minus the smaller function. Between negative 3 and 4, the line is above the parabola. You can use 0 as a test point. Use anything between negative 3 and 4 as a test point. 0 is an easy one. If you substitute 0 in for x, we have negative 9. Here, if you substitute 0 for x, you have 3. So from this point to this point, the line is the greater of the two functions. And this is the region that we're interested in. So we have calculated the area of this region right here by integrating from negative 3 to 4 of the line minus the parabola.